Okay, good morning. Another problem. So we have this one. Uh, if the cost of electricity to produce magnesium by the electrolysis of molten magnesium chloride, molten magnesium chloride, it talks about the ionic form of usually solution. Molten form, it is usually magnesium ions and chloride ions in a solution. So, but anyway, it's $155 per ton, 155 per ton of metal. What is the cost in dollars of the electricity necessary to produce? So we have 10 tons of aluminum, 30 tons of sodium, and 50 tons of calcium. So we'll start with 10 tons of aluminum given this data that for magnesium it is $155 per ton. $155 per ton. Okay, maybe we have our um, $155 per ton. So we write that down. I think that is needed. For magnesium chloride, actually, magnesium chloride, MgCl2. So that from your table of ions, this should be magnesium 2 plus and your 2 moles of chlorine. So again, this can be found from your table of ions. And then the amount was given, meaning your magnesium here, for depositing magnesium metal, so this one, depositing magnesium metal, you need 2 electrons. It will be magnesium metal, of course, magnesium metal in elemental form. So that's the one. And then this is $155. So this is $155. So the question now is, what is the cost of dollars 10 tons of aluminum? So this is $155 per ton. $155 per ton of magnesium ion. So I think tons here is 1,000 kilos. 1,000 kilos is equal to 1 ton. So this is a metric ton. So $155 per ton of magnesium. And then your problem A is, what is the cost for aluminum? What is the cost? 10 tons of aluminum. So for how about for 10 tons of aluminum? 10 tons, depositing 10 tons of aluminum, aluminum solid. So actually, um, there's no other given. So you can assume that you'll just be analyzing it from the formula that that you derive for the cost of the ton of magnesium. And then, of course, with respect to the half reactions. I think that's the solution for this. I think I've already tried this for one of the courses. So meaning, this is just a, you can just analyze that for you to have that amount, we can, maybe we can solve it in terms of dimensional analysis. So you usually start with a current ampere, and then you put your conversion. One column is 1 ampere second. Okay, you can cancel second, and then you can multiply here by time. Usually for electrolysis, you have your time and ampere. Okay, you have your current and time, current and time. So QIT. So I think QIT. So current and time. So that is the anyway, that formula talks about, I think that is the voltage. But anyway, here we know that column per second, and then we multiply it by time. We have somewhat column that is being left. And then what we do usually, so I'm analyzing just the formula, the dimensions. So what we have, current, and then we convert it to probably to Faraday's constant. So Faraday's constant is a coulomb per mole of electron. So you have already your mole of electron, so that the current is, the column is cancelled off, and then you you have your mass, of course. You have your mass. You can convert the mole of electrons into this, 2 moles of electron per 1 mole of magnesium. Then we go back to our formula weight to have our gram per mole of magnesium, gram of magnesium per mole. And then from here, of course, we per ton of magnesium. So if this is per ton, for if this is talking about all in tons, so meaning the cost would be dollars per all of this. So meaning this whole equation is at the bottom of the cost of having this 155 tons per magnesium. So that is dollars per ton. If we convert this, of course, from grams to tons, that is kilograms and tons. So this whole thing, let's say this is, what's this? The mass of magnesium, So dollars per mass of magnesium, mg. Now, we will go back to the question. We are now asked for tons of aluminum. So for tons of aluminum, you'd basically have a cost is equal to the, of course, the cost of, so we'll just do it in terms of um, ration proportion, probably. You can do it actually. But anyway, we can plug the 155 ton, $155 per ton of magnesium. That is given. That is for the cost of magnesium. Now, we will go back to the uh, difference between the magnesium and the, anyway, this whole thing here is the same. Okay? The whole condition would be the same except for where? This part here and probably this part here. Okay? So meaning, that's the only thing that we have to change. So meaning, since this is ton of magnesium, as you can see, you derive the ton of magnesium with the formula weight of magnesium. So we basically say, formula weight of magnesium, diba? Formula weight and magnesium with respect to, but anyway, we can just use that one per ton of magnesium. So maybe we can just plug. We go back to the we go to our periodic table. What is the magnesium? So magnesium, we'll just do it plug and chug. So for magnesium, you have magnesium here 24 30 50. So you have 24 30 50. So you have 24 30 50. So you have 24 30 50. We convert first the tons. 1 ton is equal to 1,000 kilogram times 10 to the 3 grams. So that is 1 kilogram. So that is 1 metric ton. Okay? So we've already converted the ton of magnesium to the grams of magnesium, magnesium metal. Next, we convert that one in terms of, so this is now the the grams of magnesium. We can now use the formula weight of magnesium, which is 24305. 24 30 50. So 24 30 50, just look at your grams here. So grams here must be here. 20 40 20, how much? 24 30 50. So this should be a 24 30 50 grams of magnesium per 1 mole of magnesium. Then we can now use this one because it changes only up to here. And then we can go back to the aluminum and probably use the information on aluminum. So 2040, we have 2 electrons, a mole. You have 1 mole of magnesium per 2 moles of electron. Okay? 2 mole of electrons. Now, it's already electrons here. Okay? It's already electrons. So, from there, we can now go to the reaction of aluminum. So, what really is aluminum in terms of depositing it? You can go back to the table of ions. You can see that your aluminum is an aluminum 3 plus. So basically, it absorbs 3 electrons for it to form an aluminum metal. Okay, so that means for aluminum, you have 3 electrons, mole of electrons per 1 mole of aluminum metal. 1 mole of aluminum metal, and then we go back to our um, periodic table. Periodic table for aluminum. For aluminum, that should be how much? 269815. 269815. 269815. 269815. 269815. 26 by U scooby-doo 269815 gram per mole. So 269815 grams of aluminum per mole of aluminum. So we can cancel the mole of aluminum, and then we change the grams of aluminum into tons. So again, we have that reverse. So you have grams, you have so 1000 times 10 to the 3 grams of, I think for the last section that I solved this one, I did not do all of this. We just figure it out that because this is just a nonsense. I mean, it should be cancelled. But anyway, here we are. We just continue. Grams of, now this is aluminum per 1 ton of aluminum. Okay? So basically, you now have your answer. That is, your number at the top would be 155, then multiplied by 24.3050, then you have your 3, then your, anyway, this one is being cancelled by this. Okay, so you need not to put that, and then we say grams, sorry, the grams of aluminum is cancelled also. So the remaining unit here would be dollars. So, so no units at the top, that's only dollars. And then here is ton of aluminum. No number at the bottom, no, there is 2. There is 2 and 26.9815. 9815. So that's all. The number that appears at the bottom. Then we get our calculator. We type it down, 155 times 24.3050 times 3, and then at the bottom you have 2 times 26.985. So the answer is $209. So you have your $209.4. Anyway, $209. I think I didn't include the 10 tons. I didn't include the 10 tons, so I'll just have to correct it. Okay. So 290, this is per tons. And then you just put, this is the units for this. Anyway, this is correct. 209 per ton. Per ton of aluminum. Then we multiply it by 10 tons of aluminum. So that would just increase to 209.4 because the answer really is 209.4. So that would be 1, 2, 3. So actually you add 2 zeros. So 20,940. $20,940 per 10 tons. So 20,940. So this is $20,940. So 1, 2, 3, 4, or you could just use the 2.09. The 1, 2, sorry, 10. So you only have to put, sorry, 10. Isang zero lang pala. Ay, nako si sir. 209, 2094. Sorry. So 2094, that would be a 1, 2, 3, or 2.1. You can rather put 2.1. Or maybe you can retain is at $2,094. So that is 2.1 times 10 to the 3. Yes. $2,094. $94. Okay, so I didn't include the 10 tons. So it's just a minor error. So I'll just have to fix it at once. Thank you for listening, guys.